Yes, we're back. Let's go. I'm Hamish, but a lot of people like to call me sometimes. But so let's get started, man. So turn a bunch. So now let's say question number 2. Give me the graph of G. Oh, they give you G. Okay. So let's say they give you stuff like this. So I'm saying, don't worry about this. So this is something that's right. They give you G of X. And then they say now, give me the graph of G. Describe how. Oh, so describe how we're gonna get Y. So they give you this, and they use this to get here. Easy. So what I'm gonna do now, look, there's something called shrunk and stretch. Okay, shrunk and stretch. So start with you. So this is what we need to find here. You know what I'm saying? So shrunk is like, like look. See this here? So means you shrink is the past tense of shrink. Some people don't know what a shrink means. Shrunk means okay, cool. Now let's go. So now, whenever, excuse me. Okay, whenever if my A, what is my A? My A is the number which is in here. This number here. See that number? They give you, excuse me, this is what I give to us. See this number here? If this number here is greater than 1 and then it's shrunk, like, so if somebody give me, let's say, f of x equal to 4x, or let's say k of x, you know what I'm saying? K of x, okay, even this also shrunk. You know why? Because here we have a 1. Yeah, let's say there's no number means there's a 1, means this graph is shrunk. So how do you know when it's stretched? It's stretched only any number which is in here, any number, if that number which is close to the x, which is multiplied to x, if it's in between, it's between 0 and 1. Let's say half. So if it's a half x, let's say k of x, let's say this f of x. What does that mean? So this meaning this is stretched because this number which is with x, okay, is between 0 and 1, like a half, or 1/3, or 0.9. So these are stretched. That's what I say here. If it would have been horizontal stretch, if a is between 0 and 1, okay? But for this time, this number is more than 1. That's what I say this a, like we're showing this a, can be any number. Like I just call it a. This number here, or you can just say this number here, I'll even mark it. Let's just say this number, because our a is equal to 2, means the number which is here equal to 2. And what is 2? 2 is greater than 1. You know what I'm saying? It's greater than 1. So for that case, and then this is horizontal, shrunk. Okay? Okay. Well, the question is, okay, how if it's, let's say, -5? -5, it will be stretched. You know why? Because -5 is out of this range. So if somebody give me, let's say, k of x, let's say k of x, let's say m -5x. Okay. Is it shrunk or stretched? Oh, now I'm looking, okay. This number which is with x is -5, but -5 is out of this. -5 is less than 0. So for that case, that's going to be horizontal, stretch. Horizontal. You know when we say horizontal? Because this has to do with the x. You know, Cartesian plane, this is x. So, you know what I'm saying? So for this case, if you look at for this number here, this number is, you see, is bigger than 1, because for this to be stretched, it has to be between. So it's bigger than 1. So since it's bigger than 1, means this stuff is horizontal, shrunk. So shrunk, if it's out of this range, means it can be any number. Any number. This represents any number, which is out of this range. Can be 2, 1.5. Oh, so this gonna be stretched. You know what I'm saying? Excuse me. It's gonna be shrunk. So if the number, okay, is the number within this range? If it's within this range, and then we say stretch. I wrote here stretch. But if it's out of this range, like let's say 2, 5, -3, -1.5, means it's not in this range. And then if it's not this range, you know what I'm saying, it means it's out of here, that's going to be what? Shrunk. Okay, so for this case here, and why do we say horizontal? Because it has to do with the x-axis is horizontal. So for that case, for now, we're going to say y equal to g of x, means I'm going to start with y because we want to prove that. So I'm going to have to start with this part here. So y equal to g is horizontal shrunk. Why? Because this number is 2, and what is 2? 2 is out of this range, that's what I say shrunk. But it could have been horizontal stretch if the number was between 0 and 1. We're done for the first one. Let's go for the number 2. Let's go. Let's go, big boy. Oh, let's go. So now number 2. Let's say given a graph of no, it's not number 2. The continuation. I'm sorry, the continuation. Okay, so now we want to go. How are they going to get negative? Negative, anything, whenever you have a negative means you reflect along x-axis to get negative. You know what I'm saying? So that means, so we have already now g of x, g to x, g. So from here, let's get negative. So we say to get negative g to x, what that means this graph, then okay, you can say the shrunken graph had been reflected along x-axis. You know what I'm saying? So you say y now equal to this. So the shrunken graph, shrunken is being shrunken graph reflected along x-axis. Because now it was positive, but now you see it was positive. This one, it was positive, but because we want to get here, means from here it must have a negative. It was positive, so when you put negative means, for example, look, if I have this is 2 and 4, if this same coordinate reflects along y-axis, this is y-axis, like a mirror, means this coordinate is going to become here, it's going to become negative 2. The value of x is going to be here, negative 2, but the value of y is going to be the same. You know what I'm saying? So for you to make the value of x equal to negative, no, it has to reflect along what? Along y-axis. You know what I'm saying? So that's what I say the shrunken graph means this graph which has been shrunk, it must reflect along what? Along what? It must be reflected along, across. So I'm saying, let me say across. Across the x-axis means it must come here. Or it's reflected here and then it's going to cross, meaning this x-axis is going to be here. It's going to be reflected across is the best way. Across what? X-axis. Okay, cool. Now we go. So we're done with it. Now we go for the last one. So for the last one, we see there's some units here. So in y, whenever we add something, makes you move up. If you minus, you move down. Oh, so this graph, which have been reflected across the x-axis, it was moving 2 units upward. So the graph was moving what? The above shrunken graph and refracted graph. Okay, so you just continue what you say here. So the above shrunken graph, because this is shrunken, this one is shrunken and reflected. So the above shrunken graph and the reflected graph was moved. How many units? 2 units upward. 2 units upward. You know what I'm saying? Upward. So we're done, man. So that's how you do, you know? Okay, so now in general, how are we going to say? So in general, you're going to have to say the whole sentence. The graph is horizontal shrunken, and then the the shrunken graph reflected along x-axis, and then the above shrunken graph reflected was moved or was shifted, moved or was translated. I think it's good to say was translated. So translated the base one. Was translated. 2 units upward. Okay, so now let me say one sentence now out of this. You know what I'm saying? So you know how to do it? So we can say single sentence. So y equal to whatever they ask us to find, g to x plus 2. So how are we going to say, how did you get this from g of x? Okay, so now this graph, general, I mean all of these, how did you get? We say negative g 2 of x, negative g 2 of x, e 2 of x plus 2, e so was horizontal. How to say which horizontal one? Horizontal. Shrunk, and then after that was reflected Across x-axis was reflected, is, and then, or was, and then reflected across x-axis. And then after that, what happened? After reflected across x-axis was what? Was translated, and then translated, and then translated. 2 units upward. We out. We done. Easy, man. Oh, we out. Hey.